Okay, we're going to solve by using the square root method. The square root method is a quick, short method. You do not, if you notice right here, you do not have a middle term. You've got your quadratic term and a constant term. In this method, you want to isolate your quadratic term. So we're going to subtract 100 from both sides and just take the square root on both sides. Now when you take the square root, when you're solving, you have two answers, and you're going to put a plus minus in front of the square root. Now if the square root can be reduced, you have to reduce it, and we know that normally speaking we should not have a negative under the square root. But in this case, we're going to use our imaginary numbers, we're going to use our complex numbers, and we're going to break this up. If you remember that the square root of -1 is I, and the square root of 100 is 10. And we normally write this as plus minus 10i. Even though I is a number, it's considered, it's treated like a variable, and you write it after your constant number 10. No, it's not constant number 10. We're going to do another quick one by solving by using the square root method. Again, in this method we want to isolate the square term, so I'm going to add 18 to both sides. This gives me y squared equals 18. So once you have isolated the square term, you're going to take the square root of both sides and you're going to add your plus minus in front of the radical. Okay, well, this radical can be reduced. And how you determine that is you think of your perfect squares, your 4, 9, 16, 25, 36, etc. And think of the biggest square root, perfect square, excuse me, that will go into 18. So 9 goes into 18. So you take your square root and you split it up into 9 times 2. There's a property that says that you can split your square root up into two factors that are square roots. We can reduce the square root of 9, which is 3 square root 2. So your answer is 3 radical 2 and negative 3 radical 2. You can leave it as plus minus, or you can separate them. So for my last example, I have 0 equals parentheses x minus 3 squared minus 49. And we're going to solve by using the square root method again. I just want to point out later in the next couple of days, if this was f of x or y equals, this would be in our vertex form. So you might want to pay close attention to this. We might use this later on. Again, I'm going to isolate the square term. Now the square term is this quantity, x minus 3. I'm going to add 49 to both sides. Okay, I've isolated my squared term, although the term is a group. I'm going to take the square root of both sides again. That undoes the squaring. They undo each other. They're inverse operations. Here's where I'm going to add my plus minus 7. So now I'm going to add 3. I'm going to write this out as two different problems equations so you can see fully what I'm doing here. So I have the positive 7 equals x minus 3, add 3 to both sides, and I get x equals 10. Over here, for my second solution, I'm going to add 3 to negative 7 and get x equals negative 4. So my two answers are negative 4 and positive 10.